Alright, so in this video, I'm going to go over the Pythagorean theorem and the converse of the Pythagorean theorem. This is going to be pretty much short and sweet because I know you've done this before. It's not really new information for you. So I'm just going to hit the main points just as like a refresher course for you. So first of all, this is the Pythagorean theorem, a squared plus b squared equals c squared. It can only be used with right triangles. The A, the B, and the C are referring to the three sides of the right triangle, okay? The C always has to be the longest side, which is called the hypotenuse. The longest side is always directly across from the right angle, okay? Does not matter which of the legs you label A, which one is B. What matters is that your hypotenuse is always C when you're plugging your values in, okay? So let's do our first example here. Feel free to draw this triangle down on your own paper. I have 5, 12. I'm solving for C. So I labeled it for you. I set it up for you already. But this is, as you can see, is across, as you can see, is across from the right angle. So it is my hypotenuse. So I'm setting this up. I have 5 squared plus 12 squared equals C squared. Okay? Now, when you are solving these problems, you're not in middle school anymore, so your answers do need to be a simplified radical. So just keep that in mind, like when you're doing the distance formula, I don't want a decimal for your answer, I want a radical. But this will be 25 plus 144 equals c squared. When I add this together, I get 169 is equal to c squared. So now I just want to get the c alone. So to get rid of that 2, I'm going to square root both sides. So I have c equals the square root of 169. Now you need to break this down, or if you recognize your square roots, put this in your calculator, you know this is a perfect square root, it's just 13. Okay? So that was a pretty easy one. You didn't have to worry about doing the factor tree. So that's it. Another final answer. C is 13. Now let's do a second example. And I can move this up, so let's do that. Beautiful. Alright, so this is 7, 14, and B. So this triangle is kind of like, not upside down, but it's sitting on its hypotenuse. So regardless of how the triangle is positioned, your hypotenuse is always across from the right angle. So 7 squared plus B squared equals 14 squared. Okay, now let's solve. 49 plus B squared equals 196. You're going to subtract 49 from both sides. I get b squared equals, I believe it's 147. Okay, again, I don't want b squared, I want b. So I have b equals the square root of 147, but let's see if we can break this down. I know it's not a perfect square root. So if you want to pause the video, see if you can do it on your own, because some of you need practice with this skill. This is an odd number, so I would start with dividing by 3 or dividing by 7. I know it's not divisible by 5 because you have to have a 0 or a 5 on the end of your number. But when you divide by 3, you get 3 and 49. This is 7 and 7. So 7 root 3 would be your final answer. If you wrote this as a decimal or you left it like this, you would not be completely finished. If it was a test or something, you wouldn't get full credit. So just make sure you're simplifying your answers. And that's your B. There it is. Now let's cover the converse to the Pythagorean theorem. Okay? Now the converse in math, right, we're not talking about a pair of shoes. Converse usually means you kind of flip something. You go the opposite direction. So the converse of Pythagorean theorem says if a squared plus b squared equals c squared, then you have a right triangle. So instead of being given a triangle that's marked with a right angle and asked to solve for a side, now I could give you a triangle or even just 3 numbers and say, tell me if this is a right triangle. So the way that we know if something is a right triangle is just by plugging these into Pythagorean theorem. If it works out, then bada bing, bada boom, we've got a right triangle. So I don't fill in the equal sign because I'm just checking to see if the sides are equal, right? So I know this is the longest side, the 5, so that goes in for my C. So this gives me 9 plus 16. I get 25 equals 25, so this would be a right triangle. Okay? You see how we're doing the same thing, but instead of solving for a missing side, knowing it's a right triangle, I'm giving you all the sides, I'm asking you if it's a right triangle. Still doing Pythagorean theorem. Okay, second example, and you can see it's not very difficult, so maybe you could just pause the video and try these next 2 examples. But let's plug it in. 12 squared. Now don't fall into the trap. Just because I put the 20 there, it doesn't go in for B, right? The longest side is always the hypotenuse. So I've got 144 plus 256, and I've got 400. So what I have is 400 equals 400. Sorry. Right triangle. Alright, our last one. Square root. How do I... Okay, well, first of all, you just have to figure out, is this my C? Is it the hypotenuse? I don't know, just square root of 41. I mean, I could guess, but if you just put it in your calculator, the decimal is 6.4. Now, I don't want you to plug 6.4 into your equation, but that tells you that this is your longest side. So we have 4 squared plus 5 squared and a square root of 41 squared. Okay, we're just checking if they're equal. 16 plus 25. Now, when you plug this in your calculator, if you can see that, right? Square root of 41. Make sure you just plug it in correctly. Oh, I get 41 back. That should not be a surprise because the square root and this little 2 jaunt right there, they're just undoing each other. It's like adding 5 and then subtracting 5, or it's like multiplying by 7 and then dividing by 7. If you take the square root of 41 and then you square it, you're going to get 41 back. So in this problem, I get 41 equals 41. Another right triangle. That's the converse. Thanks for watching.